Hi. So I just wanted to do a little tour of the Juno-6 and explain how it works. So this came out in 1982. This is the first of the Juno line. It's 6 notes, polyphonic. It was Roland's first and one of the first. What am I trying to say? Low cost polyphonic synthesizers. Roland at this time had before the Jupiter 8, but it was an extremely expensive machine. They figured out that they needed a budget offering. So if you know anything about Greek mythology, well, Roman is Zeus is Jupiter, so his hero is Juno, hence the Juno. Now, it's a very strange machine in a lot of ways. 6-note polyphony. It's very simple. You have an arpeggiator, hold and key transpose. The arpeggiator has got range. It's got modes. This is the LFO with a auto and manual switch. The auto and manual switch relates to the bender board, which is the LFO trigger there. There's a rate and a delay time. So the big innovation is that it doesn't use voltage control oscillators, but it uses a digitally controlled oscillator. What does that mean is that you have an analog oscillator, but the frequency is locked to a digital clock, hence that the tuning is a lot more stable. So you could turn it on anytime you want and it will pretty much be bang on where it's supposed to be. You've got it's 6 oscillators, 6 notes, 6-note polyphonics. So you have a 6 complete synthesizer chains: DCO, VCF, VCA, VCA, LFO. So the HPF, this is a bit of a hidden secret, shall we say? Something that's not advertised. This is where it is in the signal chain is slightly misleading. Actually, if you looked at how it works, this actually belongs here or something like that, if I would argue. Okay, you've got the envelope. The VCA has no. The VCA you have. So you have the long. Sorry, we'll go back to there. High pass filter. The high pass filter actually is only a high cut. It's not per voice. You have one high pass filter, which is in fact after the VCA. That's before the chorus. So technically, this bit belongs here. Okay. It's analog, low pass filter resonant. The envelope with a polarity switch, the LFO, keyboard, which is filter follow, and VCA, and here you got the legendary chorus, which is what really makes this machine in a lot of ways. This thing sounds fantastic even without it, and it's one of the best beginner synths because it's so simple and you can't make it sound bad. It's literally one big sweet spot. These go for fairly high prices these days. These used to be, in the 90s when I got into this, they were like 100, 150. You get these very cheap. You get these for $50. But it's rare to find one less than $2,000 these days. So I'm going to explain to you how it works, and we'll do a little tour of the insides. So we'll just turn it off. Okay. So let's have a look at the insides. Right. It works from left to right. That's you got inlet for a high voltage inlet, but with a with a fuse. That's a transformer. The transformer generates two AC voltages. One is a 10 volt AC supply, which gets turned into the 5 volt. So it generates the 5 volt from the 9 volt AC. That runs all digital logic, digital circuits, and that comes out in those two green wires, the green one and the orange one. That's the ground, and the 5 volts for digital stuff. Then you've got, and that's basically comes out of this is the voltage regulator for it. It's a 7805, your bog standard voltage regulator. That's the bridge rectifier for it. One of these caps, I think it was this one, is the main filtering for it. And then you have the two analog rails. So this is the ground for it, and this is the -15 and plus 15. That's generated by this dual tracking chip. It's a dual 15 plus and minus 15 DC regulator. It's the Toshiba TA7179. This is essentially a licensed copy of, I believe, the Motorola MC1468L, which is a very common chip. It used to be a very common chip. It's a little bit harder to find, but there are replacements for it. It's not too difficult to do a replacement board for it. There are replacements for it, thank God. So if this thing dies, your Juno will work, but will make absolutely no sound, because the two plus and minus 15 volt rails are generated by it. So that's the power supply board. Over here is the meat of it. This is the main board. Now, this main board is exactly the same on the Juno-6 and the Juno-60. So I'll repeat that. It's the same on the Juno-6 and the Juno-60. The main sound making bits between the two synths are exactly the same, hence they do sound exactly the same. What happened was that I think the year before, Korg had released the Poly 6 in 1981, and they were in a rush to release this, I think. Hence, if you look over here, there's a header that's not populated. That's used for the memory part on a Juno 60, but you can still have it. So you can use this board in the Juno 60. You would just have to install a header here to connect up to the memory board. Okay. So how this works is you have essentially 6 complete synthesizer chains. Hence, you'll see 6 circuits being duplicated across the thing. So this is your oscillators. So it's up here when it says waveform. This generates your waveforms from your digital clock, right? And what you'll notice is over here you've got the filter chip, which is the IR3109, and you see that you get 6. The same part is repeated 6 times, hence your 6 voices. Yep. It's 6 voices. Down here, your 6 VCAs. This is the BA662. It's an analog chip containing of a single transconductance amplifier and a buffer, and that's summed all together. And this is a op-amp chip that sums it all together. You can, when you calibrate it, you place your probe on these things. This is your headers for the 6 voices. There's most of the circuitry inside here is standard, except for the bits that that are proprietary by Roland, which is the 3109, which is that one, the BA662s, which is the VCA chips, and these ones are the envelope chips. So the hardest to replace if you have one die for all the chips in this machine is this one. There was a guy who was doing replacement modules for a while. Unfortunately, he stopped that. So if one of them dies, you might have a bit of trouble finding one. Okay, so you got you've got six signals that you have to treat. Basically, so you have six synthesizers, essentially in one, that you have to send all the call a signal, but you have one panel, so all the signals have to be multiplexed, right? They have to be mixed together and then sent out to each individual voices. That section is done over here. All of that is done over here. You got a whole bunch of analog switches. You find a whole bunch of analog switches there. So these are all 451s and various op amps. The brains of the operation is this thing that's controlled by this guy over here. Now, this is the 8049, originally Intel by Intel. This is a microcontroller that essentially is still used in some form up to today. It was replaced. This is the MCS 49 series. This is replaced by the MCS 51, but they're very similar. Now, this contains the firmware. This does everything. It has the firmware. There's no ROM. There's no RAM. It's all inside this microcontroller. So you have an 8049. The second number actually indicates the firmware that it's running. You'll find this chip in all other synthesizers of this era. It's extremely common. Poly 6s, Kawaiis, all sorts of things. If you look it up, you'll come across this 8049 a lot. But people might think that you're able to actually might think that you can replace the two. You cannot replace the two. They're not interchangeable. The number on the back tells you what the firmware is. So a Juno-6 or 60 can run off this. Has to have this one, which is 238 on the main board, or you can all use the 380. The 380 was later on. You see 380 or 238 here. There was some sort of bug with some notes, some not playing in the lower. It's in the service manual on the lower. In some situations, one of the notes will not play in some arpeggiator mode, but was very rare, and that was all fixed there. So later ones will have something exactly the same chip, but it's 380. So before I mentioned digital clock is these two. It's generated by these two. This is also an originally Intel chip, very commonly found in computers. This essentially generates, each one generates three clocks for this. There's 6 voice polyphonics. There's 3 clocks coming out of this one and 3 clocks coming out of that one. When you play a note, if you put your probe on some of the pins on this, you will see a square wave that is the pitch of that note that you're playing. Okay, what it does is it divides the high frequency clock over here by some number. The number is given to it by the CPU. The CPU's job is to drive all the multiplexing, all the signals around the board. It also reads the keyboard. It scans the keyboard digitally, right, and then sends out numbers, 16-bit numbers, to these two timer clocks, programmable timers, to then generate the DCO clock. Okay, so that comes out, and the high frequency clock is basically is over here. That gets divided by that number. Now, what's very strange about this synthesizer, I think, is it's like in the middle. It's between old and new. Is the fact that it's completely analog except for the tuning of the oscillators. The way I look at it. It scans the keyboard digitally. It multiplexes everything together, but it doesn't generate any of the control voltages. Okay, it doesn't generate any control voltages. The computer doesn't need control voltages. There's no. It's not like later on at hybrid synths where the CPU also generates. It has a digital to analog converter that generates the control voltages for the sensor. All of that is completely analog because the envelopes is generated by these chips. The LFO is actually completely analog and it's on this board up here. Okay, so we've gone there. Our signal then leaves into this board up here, and so on the 60, these two boards are not the same as on the 6. So on the 60, the memory board lives over here. On the 6 up here is the noise source, the high pass filter, and the chorus is up here. Actually, the chorus is on this board. It's on this side. So the LFO is up here and it's completely free running. However, every time you press the key, the LFO gets reset, and it's in the circuitry. So the LFO is not free running. It's each time you press the key, it's up here. So yeah, you've got up here is the high pass filter. It's also the noise source is up here as well. That gets fed down and mixed over here. So yeah, this board is interchangeable. Lots of parts interchangeable between the 6 and the 60, but not everything. So the top panels are different. On the 60 up here lives a separate 8049 microcontroller that just handles the memory. Okay, that part is done a little bit differently, but you can use this board if you add this card and put in the 6 and 60 and vice versa. I have done this. This particular unit came here for small faults. It had a lot of noise on the output because some of these caps were on their way out, but its main problem are the sliders. The sliders were on the 6 and 60. The biggest issue is the sliders get stuck, and this now has a new set of sliders. What will happen is that you'll move this and it'll feel horrible enough and they get stuck to about there or something and you can't move them any further. In fact, if they're stuck, my advice is not to push them. You either get a new set of sliders or you have to relube them and maybe save them. Yeah, that's it.